Good morning, sir.
Good morning,
Good
sir.
morning,
Morning,
sir.
sir. Morning.
Good morning, sir.
Morning. Okay. Today we discuss another test for convergence of a series, that is D'Alembert's ratio test. Screen is visible.
Yes, sir, visible.
Yes, sir.
Okay. D'Alembert's ratio test. For the statement, if a series is a positive term series, is a positive term series such that limit n tending to infinity un plus 1 by un, n plus 1th term by nth term is equal to suppose k. Then if k less than 1, then the series is convergent, and if k greater than 1, then series is divergent. But when k equal to 1, then this ratio test, that means Alembert ratio test fails. This test fails. Example: test the convergence of the series n square by 2 to the power n. So un plus 1 is equal to what is n plus 1 square by 2 to the power n plus 1, and un is equal to n square by 2 to the power n. So limit n tending to infinity un plus 1 by un is equal to
Sir,
limit n tend
positive term
bol
series means all terms are positive.
all term positive, no. There may be some negative terms, but the negative terms must be finite number of negative terms, then we can discard that negative terms. Okay. All the rest term are positive, but positive terms are infinite numbers. Then uh, n plus 1 square by 2 to the power n plus 1, 2 to the power n by n square, so limit n tending to infinity, this will be half of 1 plus 1 by n square. So limit is 1 plus 0, that is half, which is less than 1. That means, yes, by the D'Alembert's ratio test, by d was ratio test, the series is convergent. Example 2. Test the convergence of the series. Series is 2 to the power n by n cube. So limit n tending to infinity un plus 1 by un is equal to n tending to infinity. What is un plus 1? 2 to the power n plus 1 by n plus 1 cube by un is 2 to the power n by n cube. So limit n tending to infinity, this will be 2 to the power n plus 1 by 2 to the power n cube by n plus 1 cube. Limit n tending to infinity 2 into 1 by 1 plus cube. So the limit is 2 1 plus 0. So limit is 2. So that means if this is greater than 1. So greater than 1 means we can say that by D'Alembert ratio test this series is divergent. Example 3. Test the convergence of the series root n square plus 1 x to the power n when where x greater than 0. Okay, now limit n tending to infinity un plus 1 by un n tending to infinity. Now what is un plus 1? Un plus 1 is root of n plus 1 square plus 1 x to the power n plus 1 by un is n square plus 1 x to the power n tending to infinity. This will be n plus 1 by n and root over n square plus 1 by n square plus 2n plus 2 into x. So limit n tending to infinity 1 plus 1 by n and it will divide by n square. So 1 plus 2 by n plus 2 by n square into x. So as limit n tending to infinity, limit will be 1 plus 0, 1 plus 0, 1 plus 0 plus 0 into x. So actually limit is x. Now that means when x less than 1 by D'Alembert ratio test, this is convergent. When x greater than 1, then this is divergent. But when x equal to 1, then what?
Fail.
Fails.
The test fails. Okay. Okay. So test fails, that means we have to proceed again by another test, that is rabbit test, that is rabbit, RAABS. What is the statement? If un is a positive term series, then positive series such that limit n tending to infinity n into un by un plus 1 minus 1 is equal to k. N into un by un plus 1 minus 1 equal to k. Then the series convergent is convergent when k greater than 1, and the series is divergent when k less than 1, and third is when k equal to 1, then this test fails. So when k greater than 1 convergent, k greater than 1, okay, k greater than 1 convergent, and k less than 1 divergent, and k equal to 1, the test fails. So for any series to check the convergence, first we test by D'Alembert ratio test. If fails, then rabbit test. Okay. Example. Test the convergence of the series x.
Sir, rabbit test in the rabbit test convergent for k is greater than 1.
K greater than 1.
Just
Okay.
a reverse of ratio test.
Yes. Because here, look here, actually this is the reverse, right?
Oh, yes, sir.
Yes. X by 1 into 2 plus x squared 3 into 4 x cube 5 into 6 to the 4 7 to 8 and so on. So we have to check the convergence of this series first by D'Alembert ratio test. So first find un and un plus 1. So what is un? Un is x to the power n by there 1 and there 3 5. So that means 2n minus 1, and this is 2n. This is un, and un plus 1 is x to the power n plus 1 by, put n plus 1 in the place of n, so this will be 2 into n plus 1 minus 1, so 2n plus 1, and this will be 2n plus 2. Now by D'Alembert, first by D'Alembert ratio test. Un plus 1 by un limit n tending to infinity n tending to infinity xn plus 1 by 2n plus 1 2n plus 2 into 2n minus 1 2n by x to the power n, so x into 1 minus divided by 2n, so this will be 1 minus 2n 1 plus 1 by 2n 1 plus 2 by 2n, so limit n tending to infinity. So actual limit is what? X into 1 minus 0 1 plus 0 and 1 plus 0, so this is limit is x. So if x less than 1, then the series is convergent by D'Alembert ratio test. Now if x greater than 1, then series is divergent, and if x equal to 1, this test fails. Now we apply Rabi's test. Let us apply Rabi's test when x equal to 1. Now in that case, what is the Rabi test formula? N tending to infinity, n into un by un plus 1 minus 1. So this will be limit n tending to infinity n into this is un by un plus 1, un by un plus 1. So this is the reverse. That means this will be 2n plus 1, 2n plus 2 by 2n into 2n minus 1 into 1 by x, but x equal to 1, so into 1 by 1, okay, minus 1. So limit n tending to infinity, n into 2n plus 1, 2n plus 2 minus LCM is 2n into 2n minus 1, so 2n into 2n minus 1. So limit n tending to infinity, this will be 8n plus 2 by 2n into 2n minus 1, n tending to infinity. So divide by 8n, so 1 plus this will be 2 by 8n, 8n no need, divide it by 4n, 4n, that means this will be 2 8n by 4n plus 2 by 4n, and 2n by 4n, divide 2n into 2n, so 2n minus 1 by 2n. So limit n tending to infinity, n into 2 plus 2 by 4n, and here 1 into 1 minus 1 by 2n, this. So as n tending to no, here look at here 4n, but there is a 4n square, so this will be only 2, just 2 into 2 4n, so there is another n here, and this n cancels, so limit will be 2 plus 2 0, 1 minus 0. Now the limit is 2 is greater than 1, so by Rabi's test, the series is convergent, not divergent. Series is
Convergent.
Convergent.
Convergent when x equal to 1. So finally we actually get the series un is convergent when x lesser equal to 1, and divergent when x greater than 1. Now, another example.
Sir,
Test the convergence. बोलो.
when x is
बोलो.
less than or equal to 1, in above statement you have written when x is equals to 1, it's fail, sir, in rebel states.
X equal to 1. This is convergent, right? And by D'Alembert ratio test, x less than 1
Yes.
convergent. So finally, this is convergent for x lesser or equal to 1. Okay.
Okay, sir. Okay, sir.
Okay. Example 2. Test the convergence of the series 1 by root n plus 1 minus 1. So first check by D'Alembert's ratio test. What is un limit n tending to infinity un plus 1 by un limit n tending to infinity un plus 1, that is 1 by n plus 2 minus 1 by un, that means ऊपर में होगा this n tending to infinity 1 plus 1 by n minus 1 by root n से ऊपर नीचे डिवाइड किया, so root n, and this will be 1 plus 2 by n minus 1 by root n. So limit is actually 1 plus 0 minus 0, 1 plus 0 minus 0. So limit is 1. So here D'Alembert's ratio test fails. D'Alembert's ratio test fails. So we proceed by the test of Rabi's. RAAB Rabi's test. So limit n tending to infinity un n into un by un plus 1 minus 1, n tending to infinity n un by un plus 1. So reverse of this will be root n plus 2 minus 1 n plus 1 minus 1 minus of 1. So limit n tending to infinity n into minus 2 minus 1 n plus 1 plus 1 by this. So limit n tending to infinity n into n plus 2 n plus 1 by minus 1. So divide by root n, ऊपर नीचे 2 by n minus 1 plus 1 by n. One plus 1 by n. -1.
-1 by root n, sir. 1 by root n.
-1 by n. Then how n cancel?
Yes, sir. This is the problem.
We have to cancel n.
One more substitute.
Think. There is a problem. Think,
Multiply root over n plus 1 minus 1 in upper and lower.
Hmm. 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 Wait. Yes. तो फिर इन कैसे कैंसिल होगा फिर? नो एन कैंसिल होगा बट
Can we leave the class, sir? Nothing, sir. Nothing.
No, wait. Okay, leave this portion. There is a problem in this problem. How n will be cancelled? 1 if there is. Wait. Okay, leave this problem. I'll solve this in next class. Okay, take another example. Example 3. Discuss the convergence of the series x by 1 plus half x cubed by 3 plus half 3 by 4 5 by 6 x to the power 7 by 7 so on, and while x greater than 0. Now un, what is un? Un is 1.3.5 2n minus 1 and नीचे है 2 4 6 to 2n and x to the power 2n plus 1 और नीचे 2n plus 1. Next, and now it is un plus 1. Un plus 1 is just place n plus 1 in the position of n, so this is 2n minus 1 into 2n plus 1 by 2 4 6 2n into 2n plus 2 x to the power 2n plus 3 by 2n plus 3. So un plus 1 by un. This will be un plus 1 by un plus 1 by un, all cancel. There will be 2n plus 2 by 2n plus 1 into 2n plus 3. One, 3, 5, 2n minus 1, 2n plus 1, 2, 4, 6, 2n plus 2 into x to the power 2n plus 3, 2n plus 3 by 1, 3, 5, 2n minus 1, 2, 4, 6, 2n x to the power 2n plus 1 by 2n plus 1. So cancel, this cancel and this will cancel. X 2n plus now. So this will be 2n plus 1 and this 2n plus 1 by 2n plus 2 and 2n plus 3 and there is x square. Yes, now limit n tending to infinity, n tending to infinity, this will be into 1 by 1 plus 2n, 1 plus 1 by 2n, 1 plus 2 by 2n, 1 plus 3 by 2n into x square. So limit is 1 into x square, that is x square. Now this x square greater than x square less than 1, the series is convergent by D'Alembert ratio test. When x square greater than 1, the series is divergent. But when x square equal to 1, D'Alembert ratio test fails. In that case, we find n into un by un plus 1 minus 1. So n into un by un plus 1, that is n plus 2, 2n plus 3 by 2n plus 1, 2n plus 1 minus 1. So n into what? 4n square plus 6 and 4, 10n plus 6 by 4n square plus 4n plus 1 minus 1. So limit is n into 4n square plus 10n plus 6 minus 4n square minus 4n minus 1. 4n square cancel. So 6n plus 5 by 4n square plus 4n plus 1. So 6n square plus 5n and 4n square plus 4n plus 1. Now divide by n square. So this will be 6 by n square, 5 by n and 4 plus 4 by n plus 1 by n square. Now take limit. Let's take limit un by un plus 1 minus 1, limit n tending to infinity, 6 plus 5 by n, 4 plus 4 by n plus 1 by n square. So now limit is 6 plus 0 by 4 plus 0 plus 0, 6 by 4. That means 3 by 2. That is greater than 1. So
Divergent.
now we say that convergent.
convergent.
by Rabi's test.
Rabi's test, yes, sir.
Rabi's test, the series is now the series convergent by by Rabi's test. That means the series finally we get here what? Finally we get the series is convergent when x square less than equal to 1 and is divergent when x square greater than 1. ओके ठीक है चलो नेक्स्ट है अनदर टेस्ट ओके चलो थैंक यू